Hello, and welcome to Remcom's booth at IMS 2018. I'm Jeff Barney, the Product Marketing Manager, and Remcom develops electromagnetic simulation software. We're here talking to engineers about throughput calculations and how you may calculate throughput for a new antenna design. And this has been coming up quite a bit lately just due to 5G technology. So I've pulled together a couple of slides just to answer that question for you. So if you want to calculate throughput for an antenna design, there's three main components to the workflow. One is that you have to perform the antenna element simulations. Once you have that antenna characterized, you then need to provide a channel model. And so this is where you'll set up a 3D environment to either propagate through a house or through an urban scene. And then once you have that channel model, you can then perform your throughput calculation. So I'm going to go into each one of these in a little bit more detail. So for the first component is a full wave simulation where we are actually characterizing the antenna. So we're going to be importing the 3D CAD model, defining materials, setting up an excitation, running a simulation, and from those results we can look at a handful of things. There's surface currents on the antennas. You could look at S parameters to see the isolation between the antennas, and you can also look at the 3D radiation patterns. You'll see that there's no throughput output here because you cannot calculate throughput just based on the antenna design and simulation itself. So you take this information and then you have to set up a 3D channel model to go with it. So this example here is just a house. It's 2 stories. We imported the 3D model, so the building structure comes in, the floor plans come in, any type of furniture, stairs, windows, doorways, and the material properties are set up for those as well, so glass, carpet, drywall. As part of the channel model, you have to define where the transmitter goes, so you can think of a Wi-Fi access point. There might be one upstairs and another one downstairs, and then you also have to define where you want your receivers to go. So that antenna that you simulated, and then the previous step, you bring it into here and you place it throughout the house. You could either put it in a couple of places, or you could just put up a grid of receivers, and there might be 1,500 receiver locations in this home. We'll then run a ray tracing simulation and calculate what is the received signal from each one of the transmitting elements to each one of the receiving elements, and that'll give us a matrix that connects transmitters to receivers. Once we have that matrix, well, then we can do the communication system analysis, and this is where we calculate throughput. So this is a graph. Across the bottom is throughput in megabits per second, and then along the y-axis is the cumulative distribution. And so what this is saying is that, so for example, we could be looking at a Wi-Fi antenna that can operate at 802.11n and 802.11ac. And the graph on the left would be for the N protocol, and the graph on the right would be for the AC protocol. And that just shows that we're getting an increased throughput, over 200 megabits up to 400 megabits per second for 802.11ac versus 802.11n. So we could be looking at different Wi-Fi protocols, we could be looking at different antenna designs, but essentially what we're doing is calculating throughput and comparing that for 2 different things. So if you have any questions about that, feel free to contact us. You can either reach us at remcom.com, or if you're at the IMS show, please stop by our booth. The example that I showed you was just a Wi-Fi example in a house, but we could also be showing you an outdoor example, an outdoor to indoor example, and then other frequencies, so 28 gigahertz, 60 gigahertz, and the associated protocols with that. So thank you for your time, and please let us know if you have any questions. Thank you.